Hello Math 30-2, welcome back. Today we are going to learn how to evaluate or solve for logarithms, okay? So here they have just a little thing for you to start off, but I'm going to start off with class example number 1. Alright, it says here, log 3 base 81. So that looks confusing right now, but we could always conform this into exponential form. That is saying 3 to the x is equal to 81, right? Well, I'm going to make this into the same base, so they're both in base c, 3. So I'm going to 3 to the x is equal to 3 to the 4, which is the same thing as x is equal to 4. So then log 381 is equal to 4, right? Simple. It's kind of like exactly what we were doing last lesson. Here we're going to look at this one. This is saying 4 to the something is equal to 64. Well, this is the same thing. 64, if we change that base, that's the same thing as saying 4 to the power of 3 is equal to 4 to the x. Therefore, x is equal to 3. Thus, log 64 is equal to 3. Okay, that's it. This is equal to 3. I'll just circle my answers. Now let's take a look at the next one. We're saying log 7 is equal to 7. So 7 to the power of something is equal to 7. This is an interesting one. Well, that's to the 1. So x is equal to 1. So log 7 to the 7 is equal to 1. Now looking at this here, what if I have log 8 to the log base 8, 8. Right? If I'm saying log base of 8, 8. That's going to be 1 as well. Log base of a million, 1 million. That's going to be 1 as well. So if these two numbers are the same, our base and our log number, then it's just going to be 1. Here's the next one. Log 12, log base 12, 1. Okay, so base 12 of log, 1. So base 12 of log 1. So let's take a look at that. That is 12 to the x is equal to 1. Well, anything to the power of 0 is equal to 1. Now that means we're going to end up having log 12, x must be equal to 0 then, log 12 to the 1 is equal to 0. Okay? Alright, so here we're going to look at our second example, and it's just saying determine the value of log b1. So autofocus here a bit. So we want log b1. Okay, so that's saying b to the x is equal to 1. Well, anytime we have log b and it's equal to 1, that's going to be, we kind of did it in the last lesson, log b1 is equal to 0. So anytime we're logging 1, it's going to be equal to 0. It doesn't matter if it's base 4 log 1, it's going to be 0. Anytime we're logging 1, it's equal to 0, taking the logarithm of 1. Let's try this one. We want the logarithm of b. We're going in base b and the logarithm of b. Well, that's saying b to the x is equal to b. Well, so then that is just going to be 1. So anytime we're in the base logarithm and we're logging the base, it's just equal to 1. Okay? There we go. Our next question says, evaluate the following. So we have 2 log. So we have 2 log x 12. Okay? Well, here, log 8. So the logarithm in base 8, and we're logging 512. So that's going to be, first thing we're going to look at is this part here. So that's going to be 8 to the something is equal to 512. Well, this is the same thing as 8 to the power of something. Just dividing your calculator 512 by 8 so many times. I'm going to end up getting 8 to the 3, and this is going to be 8 to the x. So this is x is 3. So this is really saying 2 to the 3, because log 8, 512, is equal to 3. This part here is just equal to 3. So 2 times 3 is 6, because we want to multiply whatever this value is by 2. Okay? Now let's take a look at the next one. It's saying log 2, 1 over 32. There's a whole percent there. All right. So this is complicated. It's saying 2 to the x is equal to 1 over 32. Well, this is in base 2. Can we put this in base 2? Yes. So first of all, I'm going to say 2 to the x is equal to 32 to the negative 1. Now, I could change this into base 2. How? Easy. Just basically how many times it's in base 2. So first of all, we're not in fractions anymore because this isn't. So we have 2 to the x is equal to 2 to the negative 5. So then log 2, 1 over 32 is equal to negative 5. All right? Here we go. Next one is log 5, the root of 125. So that's saying 5 to the x is equal to square root of 125. Let's put this into base 5. This is the same as 5 to the 3 square root. Well, what is that the same thing as? 5 to the 3 over 2. So 5 to the x is equal to 3 over 2. Therefore, log 5 root 125 is equal to 3 over 2. All right. Here we're going to take a look at my last question of this section of converting in. And so it wants us to evaluate 1/3 to 27. So the 1/3 base of log 27. Okay, so base 1/3 log 27. So that's now saying we have 1 over 3 to the x is equal to 27. Well, once again, this is in fraction form, this isn't. So I have to flip this, take the reciprocal. So we have 1 over 3 to the x is equal to 1 over 27. Now we are talking. We are kind of similar. And I'm just going to cube root all this. So I get 1 over 3 to the x is equal to 1 over 3. Because 3 times 3 times 3 is 27. Makes it nice. There we have a 3. So now I get log 27 is equal to negative 3. Because this is all negative. This is negative 1. Alright? Okay. Next one here, we're going to look at log 4. I'm going to zoom this in because this is very small. Okay, so we have log 4, and we have 4 to the power of the base 4 of log 16. So I'm going to look at this part first. That's saying 4 to the power of x is equal to 16. So then log 2, or log 4, and we're going to have 16 is equal to 2. Because this is the same thing as 4 squared is that, right? Okay, so 16 is equal to 4 squared. Now I'm going to continue this. I'm going to go and look at it. And we know then that this is equal to 2. So 4 to the 2 is equal to 16. That's it. Okay? All right, well, let's take a look at this one. This one looks very complicated. We have subtraction signs. We have a subtraction sign in there. We have the regular log. It's not that complicated. All we do is first look at what we know. This is saying 1/3 to the power of something is equal to 1 over 8. Sorry, 1/2 to the power of something is equal to 1 over 8. So I take a look at this. 2 to the power of 3 is equal to 8. So that's here saying log, we know 1 over 3, 1 over 8 is equal to 3. Now let's try and solve for this one here. I'm just going to put that to the side. And we know that 1 over 2 to the power of something is equal to 8. Okay? Well, what is that equal to? Well, this is in the wrong way. We want to flip it. So I'm going to say is equal to 1 over 8 to the, that's an 8, to the negative 1. Now 2 to the 3 is equal to that. So this is 1 over 2 to the 3 to the negative 1, which gives me negative 3. So it's 1 over 2 to the negative 3. So x is equal to negative 3. Therefore, we end up getting, I'm just going to put this in here. So we have log 1 over 2 to the 8. Log base 1 over 2, and we're log 8 base 1 over 2 is equal to negative 3. So here, if we look at this, we have this one first, which is equal to 3. 3, subtract, and then this one here, which is negative 3, which will give me 6. Okay? All right. Now we're going to look at common logarithms and how to do it. So we're going to look at how to do this more or less in the calculator. If we're doing this here, I'm just going to zoom back out. It says evaluate log 1000 by converting to exponential form. That's what we've been doing so far. So remember this, there's base 10 there. So we're going log base 10 is 1000. Isn't that the same thing as saying 10 to the x is equal to 1000? Well, that's the same thing as saying 10 to the 3 is equal to 1000. So then this here is equal to 3. That's my answer. Okay? Now, or else we could just use the log key, which is a lot faster. So let's take a look at this. I'm going to use my log key, turn it on. I'm just going to put log, because our calculator is always in this base. So that's just going to give me 3. Exact same answer. Now we're going to look at the natural log. Natural log is when we use this thing here, which is e. So it says, evaluate the following logarithms to one decimal place if necessary. So we're going to look at that. We have natural log of 5. So let's just do a log 1 is equal to 1.6. Now this one here, natural log e. So anytime we say log of base e logarithm, that's the same thing as saying ln. So this is the same thing as natural log of 5, which is 1.6. Okay? Now the last one is natural log of e. Well, the natural log is the same thing as saying log of base e. For base e and log. And then we're saying we're logging e, but we're in base e. Well, this to this, that's from our log before. This is just going to be equal to 1. Okay? Because log e is the same as the natural log. Alright. So now we're going on to the next class, the next part here, which is based on the change of base identity. Because our calculator now, you might be trying to figure out, well, what do we put if it's not in base 10 into our calculator? How do we type that in? It's very similar to what we did when we were graphing. So what we're going to do is, here I have log 4, 1024. So I'm going to just punch that into my calculator. I'm going to put in this part in my calculator like this. It's going to be log 1024 all over log 4. So the base goes on the bottom, and what we're logging goes on top. It's just done right here. This is our formula. So what does this equal? When we put in our calculator, it's very simple to do. I am just, make sure you see it, I'm just going to go log 1024 bracket, and we were in base 4, I believe it was, divided by log 4 bracket. And that is equal to 5. So this is just equal to 5. See how fast it is on a calculator? Easy. This one here is saying 3, and then we have 2, base 2 logarithm of 1000. So let's take a look at that. That's going to be log 1 over 1000, because that's my x value, all over log 2. And then whatever that answer is, we multiply it by 3. Okay, so let's put this into our calculator. So first thing we're going to do are logarithms. Always do it in one step when you're doing this division of logarithms. I like to do it that way. So we're going to go log, and it was 1 divided by 1000. Okay? And then this is all divided by log, and what base were we in? 2. Okay? So we push enter. I'm going to get negative 9. Now we have to multiply that by 3, because that's what it tells us to do. It says multiply that by 3. So we end up getting negative 29.9. I believe we want to, nearest 100th. Yeah, 0.90 if I round off. Okay, so that's the solution for that one. The next one here has log. Zoom in a bit so you can see. It's saying log 6 to 16. And we're in base 6, log of 216. So that's 6 to the x is equal to 216. But we're going to do this in our calculator, so let's first do that. So we're going to go log 216 bracket divided by log 6. So that gives me 3. So we know this whole exponent, we looked at the complicated part first and do that first, is equal to 3. So that's saying 6 to the 3. All right? So now 6 to the 3. 6 to the power of is 216. Okay? Now let's take a look at this last one of this style. It is saying we want to do the log of this here. So once again, this looks very complicated, but we're just going to put it all in our calculator and make it easy. So I'm going to say log, and we have square root of 1 over 1024. Okay, so let's put that in. So we have log, and we're going to square root of 1 over. Put in my brackets, make sure they're put in. 1 divided by 1024 bracket, and we're out bracket. And we're dividing that by log 2, because that's my base, the bases. So we divide that by log 2. And I end up getting negative 5. Oops, this is all divided by log 2. My answer is negative 5. Okay? So here we go, 3a. It says, explain how to graph using the graphing calculator for this here. So we want to graph this using the graphing calculator. Well, first of all, we have to put this into y equals. Now it's in base 7, and my x value is x. So we're going to have to say log x divided by log 7. So let's put that in my y equals. We're going to go log x, and then we divide that by, make sure you close the brackets, log 7. And we're going to graph it, and it looks something like that. I'm going to put my window back to normal. Okay? So my graph looks something like that. It's barely noticeable. Oh, still thinking. Yeah, let's check my window. Okay, graph. Okay, there we go. It looks like that. It froze last time. Okay, so there's my window. So pretty much this is saying at 7, when x is 7, y is 1, right? That's one thing we know. So I'm going to draw this here. When x is 7, y is 1, and my y-intercept is 1. Or my x-intercept is 1, when x is 7, y is 1. All right? Now it also, so we sketched it, and we know my x-intercept for a log is always 1 in these cases. So then it says use the calculator to solve the following equations. So we want to know when it's 5. So that's like saying 7 to the x is, or 7 to the power of 5 is equal to x. But we want to do this on the calculator. So to cheat my way through, to figure out my window size, I'm pretty sure it's going to be very big, we have to go 7 to the power of 5. So I know that is going to have to be my x value. My x value is going to have to be really big. I'm going to put 20,000. Okay? And my y value, I'm going to leave it at -1. And my x min is 0. And so we're going to graph this. And there we go. Well, that looks nice. Okay, now we want to know through graphing when it's equal to 5. So my y value is 5, and we have to find the intersection of this. And we all know how to do that. We're just going to go second, calculate, and we want the intersect. And so we get close. Where's it close to 5? It's around right there. So I get 1,600, or 1,687, 16,807 for that. So I put that in, I end up getting 16,807. So we go back to this here, and I'm going to quit and see, and that's exactly what we said when we did that way. Now the next one is a little bit more complicated to do. We already have our value. Let's figure out what this is. We're going to isolate for the log 7x. So first thing I'm going to do is plus 9 to both sides. So I'm going to get 9 is equal to 3 log 7x. Now I'm going to divide both sides by 3. So I get 3 is equal to log 7, the base is 7 of log x. Okay? So we're going to put that in my calculator. Now my y is equal to is going to be 3. Now my window for this is going to be a lot smaller because 7 squared is 49, and I'm going to just put 1000 because 7 to the power of 3 is only 343. So I'm just going to put 1000. And there we go. And there we found my intersect. When we calculate my intersect, it is going to be equal to, put it over here, 343 if we do this one. Okay, that's my x value. Alright? So solve the equations by converting to exponential, 7 to the power of 5. This one here is going to be 9. This one here is going to be, sorry, let's first do this. So we know 9 is equal to log, or 3 is equal to log 7x. So that's 7 to the power of 3 is equal to x. And that's how we solve these ones there. Okay? That's everything, which is 343. And this one, or something like that, 343 I believe. And this one here is going to be 1016.07. Alright? So if you have any other questions, don't be afraid to ask tomorrow. See you tomorrow.